So for this week, we're going to start by a very simple foundation and introduction to data mining. So the first thing is the CRISP DM process. So this one steps for cross-industry standard process for data mining. So it is a widely used industry standard framework that outlines the different major phases or steps of any data mining project. So the first step is business understanding. So here we simply define the problem and the different project goals. Then we move into data understanding. So here we collect and explore the data needed for this project. From there, we move to data preparation, where we work on cleaning, transforming, and organizing the data. And then we move to the next stage, which is modeling. So here we apply data mining algorithms and machine learning algorithms to discover the different patterns in the clean data. After that, we move to the evaluation phase. That's where we assess the model's performance to ensure that they do meet the business goals. And then lastly, deployment, that's where we deliver the results in a usable format. Things like reports, dashboards, APIs, and so on. So that's what we call the CRISP DM process. So data comes in different types. We can have structured versus unstructured data. So structured data are actually organized in tables or spreadsheets, things like relational databases, CSV files, and so on, right? And we can think of some examples like the customer's dataset or the student's dataset and so on. Whereas the unstructured data, it doesn't really fit into the row column architecture. So things like emails, images, videos, and so on, social media posts, and so on, right? The second type of data is labeled versus unlabeled, right? When we talk about labeled data, here for each of the data samples, or what we call an instance, we do have an output or a target label that we are trying to predict using data mining tools. Okay. So as an example, think of um, a patient, right? An instance can be, or a data sample can be a patient. And what we're trying to predict here is whether that patient is healthy or not healthy. That's the target variable. So this data sample is actually labeled. It does have a target variable that we're trying to predict. Versus unlabeled data, that's data that doesn't really have a target output that we're trying to predict. So you're going to be applying different type of data mining techniques to them. That's what we would call unsupervised learning. So things that we've just mentioned with Netflix, having or creating groups of customers based on their behaviors, right? So we don't have an outcome that we're trying to predict. We're simply grouping customers, similar customers, based on their watching behaviors, right? On the other hand, also, we can categorize data into continuous versus categorical, right? So think of simply numerical versus categorical. So for numerical, things like the height, temperature, income, all these are numerical or continuous outcomes versus with categorical, right? So things like groups, if we're trying to predict a product type, a user role, um, these are categorical outcomes. We can also have different types of data like time series, that's data that's collected over time intervals, or we can talk about spatial data, which is data that involves physical locations. A very important concept here that you need to remember for this week is the introduction of instances versus features for data mining projects. So what do we mean by these two concepts? So an instance, also called a record, an example, or a row in case of relational databases. So that's simply a single item or a case in your data set. Think of it as one subject you are observing, like one person, one product, one transaction, and so on. Versus a feature, also called a variable, an attribute, or a column. It's actually a property or a characteristic of that one single instance. So think of it as something you measure or record about each instance. So here, if an instance is a customer, the features corresponding to a customer could be the age, the category of the product that the customer has bought, the price, the books, and so on, things like that. So this is the main difference between what we call an instance versus a feature. If we are dealing with the student data set, then each student in this scenario is an instance, right? So if there are 100 students in your data set, then you have 100 instances, okay? And then for each student, we have features like the student age, the GPA, the student's major, the credits, right? So all these are the different features of that student. So when we say data mining, it's actually easy to mix it up with other things. So here is a list of the things that data mining is not. So data mining is not statistics, because statistics help you describe and explain trends in data, whereas data mining is actually one step further, where it helps you find patterns you didn't already know were existed. Okay, but we do use statistics for data mining to help data mining or to empower data mining techniques. That's why you have statistics as a prerequisite for this course, right? Second is data mining is not just database queries. So you do run SQL queries to retrieve specific data that you already know you want. Okay. With data mining, you are discovering some unexpected patterns that you don't necessarily already know about. And then thirdly, data mining is different from something that's called business intelligence reports, which we'll discuss probably in 2 weeks. So BI or business intelligence tools, they do summarize and visualize historical data, whereas data mining actually looks for insights that help predict what's next in the future. Okay, so if we want to summarize, statistics explains, queries retrieve, BI reports, right? But data mining actually learns and uncovers hidden patterns.